Now you're ready to look at what some students like to call the teacher's point of view, because this is in fact how I make up polynomial equations when I need my students to solve them, so that I know that they're solvable and they have the type of solutions that I want. Let's suppose that we need a third-degree polynomial for which 4 and 2i happen to be zeros and f of -1 is -50. I'm going to focus first only on the zeros, and I'm going to recall that complex solutions show up in conjugate pairs. So I do in fact have all three of the zeros that I need. I have 4, positive 2i, and negative 2i, because the conjugate pair must be there. So by the factor theorem, I know that x minus 4, x plus 2i, and x minus 2i are going to be factors. This f of -1 equals 50 is going to come into play because there may be a common factor that I factored out to begin with that I know nothing about at this stage. So what I'm going to do is I'm going to multiply this out. Now I'm going to multiply the conjugate pairs first, because conjugate pairs give the difference of squares, and that is just the quickest way to get it. Yes, x plus 2, x minus 2 would be x squared minus 4, but that I squared is going to change my sign. Then I'm going to say that x times x squared is x cubed minus 4x squared plus 4x minus 16. Now again, this may be f of x and it may not be f of x because it may be a common factor I need to distribute. How do I figure out? Well, I'm lazy, so I use synthetic division. My coefficients right now are 1, -4, +4, -16. And I know what the value of -1 is supposed to be. So the remainder theorem tells me that its value will be right here. So I'm going to do the division. -1 times 1 is -1. And I add to get -5. -1 times -5 is +5. I add to get 9. -1 times 9 is -9. And I add to get -25. So my value at -1 is not -50, it's -25, but that's easy enough to see. I need to multiply by 2. So my f of x is going to be 2 times whatever I multiplied out. X cubed minus 4x squared plus 4x minus 16. So all I have to do to finish it off is actually distribute the 2. So that would be 2x cubed minus 8x squared plus 8x minus 32. Final answer. Let's try that one more time for good measure. Let's find a third-degree polynomial for which 5 and the square root of 2 are zeros, and f of 2 is -18. Okay, again, we're going to play the little conjugate pair thing to say that my 3 zeros are 5, square root of 2, and negative square root of 2. So by the factor theorem, x minus 5, x minus square root of 2, and x minus negative or plus square root of 2 are my 3 factors. Again, I'm going to multiply the conjugate pairs first because that's the easiest thing to do. And conjugate pairs give the difference of squares, so that's going to be x squared minus 2. Then I'm going to FOIL that out to find my cubic polynomials. So that's going to be x cubed minus 5x squared minus 2x plus 10. Again, this is the base of my answer, but it may not be my exact answer. I need to evaluate f of 2 first. So I'm going to do that again through synthetic division because I just think it's faster. Especially without a calculator, it's much faster. So 1 times 2 is 2. Add, I get negative 3. 2 times negative 3 is negative 6. Add, I get negative 8. 2 times negative 8 is negative 16. Add, and I get negative 6. I need negative 18. Well, negative 6 times 3 would give me the negative 18. So my f of x is going to be 3 times my polynomial that I've already found. X cubed minus 5x squared minus 2x plus 10. So distribute that 3 through, and I will have the required polynomial. So that's 3x cubed minus 15x squared minus 6x plus 30. Final answer. So now you know the teacher's secret.